Hello, my name is Alexis. I had exam form B, and I'll be going over the problems that I got incorrect. So for question number 10, which of the following is a nonmetal? Well, nonmetal is located on the right side of the periodic table. So for our possible answers, we have sulfur, carbon, silicon, and Fr. So sulfur and carbon are located on the right side, so they are considered a nonmetal. Silicon is a metalloid. Fr is considered metal, so we know those are incorrect. For question 23, what does a molecular compound consist of? Well, molecular compound is composed of only nonmetals. So with that definition, that tells us that D is the only one that's correct, which is 2 nonmetals. Question 16, which of the following compound is 40% carbon, 6.7% hydrogen, and 53.3% oxygen? So with this, we'll have to do the empirical formula. So we're already going to assume all these percent equal 100. So we're assuming that will give us 40 grams of C, 6.7 grams of H, and 53.3 grams of oxygen. So with that information, we'll have to use that to find the molar mass for each element. Okay, so we'll start off with carbon. We have 40 grams of carbon. So in order to get rid of the grams, we have to put that on top of the original grams of carbon, which is 12.01 grams of carbon. So once we have that, we'll cross out the grams, and that'll equal 1 mole of C. So then we'll divide 40 by 12.01, which will give us 3.3 moles of C. So we got C done. Now we'll move on to H. So with 6.7 grams of H, there is 1.01 grams of H. So we cross out the grams, put that over moles, then we'll divide 6.7 by 1.01, and that will give us 6.6 moles of H. So we're done with that. Last will be oxygen. So 53.3 grams of oxygen, and then we'll have 16 grams of oxygen. Put that over 1 mole. So we'll divide 53.3 grams over 16 grams, which will leave us with 3.3 grams of moles of oxygen. So with that information, we'll write out our formula to look like this. Once we get it like this, we'll divide by the lowest molar mass, which we have 2 low molar mass of 3.3 and 3.3 right here. So when we divide each one by 3.3, that leaves us with this, CH2O. So then we'll go back and look at our possible answers. So right here we have C6H12O6. We see that this is clearly a molecular formula and it can be simplified. So we'll divide everything by 6, which will leave us with CH2O, which as you can see is what we want. Question B is already CH2O, so we know that's correct. Question C, well, that was question B, I'm sorry. For question C, we have MgCOH. First, we don't even have an Mg, so we already know that's wrong. For question B, we have CH3COOH. Well, looking at this, you know we have some common elements that we can put together. We have 2 C's, which leaves us with C2. We have 3 H and another H, which adds up to H4. And then we have 2 oxygen, which gives us O2. So altogether we'll have C2H4O2. This is also a molecular formula. We know we can simplify this. So once we simplify everything by the smallest number, which is 2, we'll get this, which is CH2O, which is exactly what we have down here. So we know our correct answers are A, B, and D because they all simplified to become this. Last, they want to know how many hours will it take if we are traveling 713 miles and we're going at a speed of 97 meters per second. So first we'll try to convert the meters per second to miles per hour, and to do that we'll set this up as you see here. Once we set this up and we do the math, you'll have these 2 numbers. So you'll divide, and then this will give you your miles per second, which is right here. You'll multiply that by 60, which will give you your miles per minute. But you want hours, so once you multiply by another 60, it'll give you your miles per hour, which is exactly what we're looking for. So once you get your miles per hour, they want to know how many hours will it take for the trip. So you're going to take your number you got for the miles per hour, you're going to subtract it by 97 because that's the speed you're going at, and it will leave you with 120 hours, and that's your correct answer. Thank you.
Thank you, Alexis. You did a good job.